Welcome to the Deep Dive. We're kicking things off today with something a bit paradoxical, I guess. Artificial intelligence.
Right.
These incredible language models, they can whip up everything from marketing copy to, computer code. And they're right, like an astounding amount of the time.
Mm-hmm. They really are impressive.
But here's the kicker.
Yeah.
They also just make stuff up. A lot.
Uh-huh.
It's like that, straight-A student who occasionally insists the sky is green with total, absolute confidence.
Yeah, that's a great analogy.
It makes you wonder, doesn't it? If an AI is confidently wrong, even, say, 10, 20% of the time,
yeah,
how can we ever truly trust it for the really important stuff?
Exactly. Imagine relying on it for something critical and it just, hallucinates a different reality.
Yeah.
And that inherent unreliability, that tendency for these large language models, LLMs, to generate plausible sounding but factually incorrect information, that's what we call hallucination.
Okay.
And it's not really a bug, it's actually fundamental to how they work.
Really? Not a bug.
Not in the traditional sense. They're designed to predict the next word based on patterns they've learned from massive amounts of text. And sometimes those patterns lead them down these, imaginative but inaccurate paths. It's the big hurdle, really, in getting AI adopted for serious enterprise-level applications. That, 10 or 20% of the time they might be wrong. That's a huge worry when you're talking about things with real-world consequences.
It absolutely is. So our deep dive today is all about this fascinating and, frankly, sometimes kind of hilarious problem of AI hallucinations.
Mm-hmm.
But maybe more importantly, we're going to explore the genuinely mind-blowing research happening right now to actually tackle it.
Yes, the solution side.
We're talking about the cutting edge of AI, the clever tricks, the techniques being developed to make these systems more trustworthy. Think of it as like the quest to ground these digital dreamers in reality.
I like that, digital dreamers.
And we're going to try and do it in a way that's clear, engaging, and hopefully makes you go, aha, a few times. No need for a PhD in machine learning to follow along. Promise.
Absolutely. And, to get started, it's maybe helpful to understand the different ways researchers even talk about these inaccuracies.
Okay.
You might hear terms like hallucination, obviously, but also ungroundedness, factual inconsistency, maybe lack of faithfulness or truthfulness. They all kind of circle around the same core issue.
Right, different facets of the same problem.
Exactly. For our discussion today, though, we're particularly interested in what's often called ungrounded hallucination in text-to-text generation.
Ungrounded hallucination. Got it.
This is basically where the AI produces information that either directly contradicts the source material it was given,
Okay.
or simply can't be verified against it. It's the AI equivalent of confidently stating something that's just not true based on the information right there in front of it.
Right, like that student analogy again. Confidently giving the wrong answer even with the textbook wide open.
Precisely.
And what's wild to remember is that these AI aren't deliberately trying to mislead us, are they?
No, not at all. It's just how they're wired. They're pattern matching machines on a massive scale. And sometimes those patterns lead them astray.
So it's not logic, it's probability.
In a sense, yes. They excel at predicting the most likely next word in a sequence, which is how they generate such fluent, coherent-sounding text.
Mm-hmm.
But they don't possess a true understanding of the world or the concept of truth like humans do. So in their pursuit of creating smooth-flowing language, they can inadvertently stitch together phrases and ideas that aren't actually supported by facts. It's not a logical error like a traditional computer bug. It's more intrinsic to their statistical nature.
Okay, that makes sense. So let's dive into some real-world examples of these AI oops moments then. Our sources are full of them, and they really help illustrate how this plays out.
Yeah, definitely. Consider a scenario. A doctor and patient are discussing a headache, right? Caused by lack of sleep. An AI summarizing this conversation completely invented that the doctor prescribed distilled water as a remedy.
Distilled water for a headache?
Yep. The actual conversation only mentioned managing stress, so you have a completely made-up medical recommendation.
Wow. That definitely highlights the danger, doesn't it? You wouldn't want an AI medical assistant just inventing treatments.
Not at all. Absolutely chilling. Or another example, an AI question answering system. It was told, Mike recently moved from NJ to WA. Pretty simple.
Okay, New Jersey to Washington State.
Right. When asked, where's Mike now? It confidently responded, Mike is in Washington, D.C.
Oops, that's a cross-country, geographically incorrect hallucination. confusing the state with the district.
Big difference. Small name difference, huge location difference.
A little like saying someone moved from London, Ontario to London, England, and thinking it's the same commute.
Exactly. Here's another classic one. Give an AI a document listing, say, Nobel laureates Anne Loulier and Katalin Kariko. Then ask it for the Nobel laureates mentioned in that text. It might come back with a list including Annie Ernaux and Carolyn R. Bertozzi.
But wait, are they Nobel laureates?
Yes, they are Nobel laureates, so the information isn't factually wrong in isolation.
Ah, I see.
But they weren't in the provided document. The AI essentially pulled in outside knowledge it has and presented it as if it was sourced from the specific text it was given.
So it's not always making up complete fiction. Sometimes it's just misattributing information or going off book, kind of.
That's a really crucial distinction, yes. And it gets even subtler. Imagine feeding an AI a recipe that's, I don't know, missing a couple of crucial steps.
Okay, happens all the time online.
Right. An LLM might still generate a seemingly complete set of instructions, just filling in the blanks with its own culinary creativity.
Which might result in disaster.
Could be a culinary disaster. It assumes a logical flow even when the information is incomplete.
Sounds like a recipe for inedible AI-generated soufflés.
Precisely. We also see hallucinations triggered by contradictory information in the input.
Okay, how does that work?
Well, if an AI is told both that no state minimum wage law exists and that 29 states have a minimum wage higher than the federal one.
Which obviously contradict each other.
Right. It can get thoroughly confused and produce a totally nonsensical output trying to reconcile these conflicting pieces of data. It's like asking someone to solve a math problem with two contradictory equations. The answer is likely to be gibberish.
It's like arguing with someone who contradicts themselves in the same sentence. You just don't know where to start.
Exactly. And it goes deeper. Even errors in the data used to train these AI can lead to hallucinations down the line.
Oh, wow. Garbage in, garbage out, potentially.
Sort of. One source mentioned instances where simple rephrasing of dates in training datasets was incorrectly labeled as a factual conflict.
So like Jan 1st versus January 1st.
Something like that, yeah. This can teach the AI to flag perfectly valid statements as errors simply because they're phrased differently. It's like learning a rule based on a flawed example.
So even at the foundational level of training data, these inaccuracies can creep in and cause problems later. That's worrying.
It is. And it's not just in free-form text generation. We also see hallucinations in retrieval augmented generation, or RAG.
RAG, right, where the AI fetches info first.
Exactly. In RAG, the AI first searches for relevant documents and then uses that information to answer a user's question. A hallucination happens when the AI's answer includes details or facts that weren't actually present in the documents it retrieved.
So even after doing its homework, it can still invent things. That's wild.
It is like a student doing research, finding some relevant articles, and then including made-up quotes in their paper.
Okay, it's a good analogy.
And sometimes these AI can even contradict themselves within the same piece of generated text that's called a self-conflicting hallucination.
So one paragraph says X, the next says not X.
Pretty much. One part of the response might state one thing, while another part directly contradicts it. It's like someone telling you two completely opposite things in the same breath.
You definitely question their reliability.
Exactly. We also see how subtle similarities in language can trip them up. Remember the calcium and magnesium example?
Vaguely, yeah. Both minerals.
Right. If an LLM is given text that clearly distinguishes their chemical properties, but then is asked to compare them, it might treat them as interchangeable in some aspects simply because they are both minerals with similar sounding names or contexts. It sees calcium and magnesium and thinks close enough, even when the details really matter.
So it's like a toddler calling all four-legged animals doggy. Semantically, maybe, but not quite right.
Precisely. Another telling example involved asking about the benefits of ice for a neck injury.
Okay, common question.
GPT-4, in this case, invented several benefits that weren't explicitly mentioned in the provided text, just made them up.
Oh, there.
On the other hand, a different method, developed by a company called Accurai, produced a response that stuck strictly to the information that was actually there. No added fluff, no invented benefits.
Okay, so that gives us a glimpse into how different approaches can yield vastly different levels of accuracy.
Exactly. It's a great sneak peek into some of the solutions we're going to talk about.
And who hasn't tried to fact-check something seemingly simple like, when did Chance the Rapper release his first mixtape? An LLM might confidently give you the wrong date, even if the correct information is readily available somewhere in its training data or easily searchable.
Exactly. It happens all the time. And one final, very clear example. Petra van Staveren, a swimmer.
Okay.
If you give an LLM context stating she won a gold medal in the 1984 Olympics,
Great.
it might incorrectly come back and say she won a silver medal in the 2008 Olympics.
Wow, completely wrong medal, wrong year.
Exactly. It gets some of the details correct. Olympics, swimming, a medal, but crucial specifics like the medal type and the year are just fabricated. It's this bizarre mix of getting some things right and others wildly wrong.
These examples really do drive home just how widespread and, well, varied these AI hallucinations can be. So the million-dollar question is, what are the brilliant minds in AI research doing to fix this? How are they working to make these powerful tools more reliable and less prone to these creative outbursts?
Well, early efforts in this area, they mostly focused on just detecting hallucinations after the AI had already generated them.
Okay, like spotting the mistake later.
Right. Researchers built models that could try to classify or rank AI-generated text based on how grounded it seemed, how well it lined up with the source information.
So giving it a score, maybe?
Sort of, yeah. These detection methods are useful for identifying when a hallucination might have occurred, but they don't actually prevent the AI from making the mistake in the first place.
Right. It's like having a smoke detector. It tells you there's a fire, but it doesn't stop the fire from starting.
That's a perfect analogy. So they could raise a red flag, but they couldn't actually correct the AI or make it inherently more accurate next time.
Gotcha.
More recent, and I think much more exciting, research is focusing on strategies that can actually reduce the occurrence of hallucinations during the text generation process itself.
Prevention rather than just cure.
Exactly. And this involves a whole range of clever techniques. Some researchers are looking at tweaking the AI's decoding strategies, basically, the way it chooses the next word in a sequence to make it less prone to wander off topic or invent facts.
Steering it better.
Others are exploring methods where the AI is prompted to critically evaluate its own output as it's being generated.
Like a built-in fact checker.
Kind of, yeah, or having a sort of internal debate. There's also work on using multiple AI agents that can debate and cross-verify each other's claims.
Oh, interesting. Safety in numbers, maybe?
Potentially. And another really promising avenue is allowing users to specify a very precise set of documents or knowledge sources that the AI must draw its information from, limiting its ability to bring in outside or fabricated details, restricting its playground, if you will.
Those all sound like really smart approaches. But I know our sources have highlighted some specific cutting-edge techniques that are showing real promise. Let's dive into those.
Absolutely. One fascinating technique is called chain of natural language inference, or CONNLI.
CONNLI, okay.
What makes CONNLI particularly interesting is that it's a post-editing approach. It works on the output that the AI has already generated.
So after the fact, but it tries to fix it.
Exactly. And the really cool part is that you don't need deep access to the inner workings of the original AI model itself.
Oh, that's practical.
Very. All you need are the original text you fed into the AI, the text the AI produced, and access to another language model through an API, like a standard commercial one. This makes it potentially very accessible for businesses and developers.
Okay, so it's like having a second AI act as a proofreader for the first one. And it doesn't require you to have built the first AI from scratch.
That's a great way to put it. CONNLI works in a few key steps. First, it takes the AI's generated response and breaks it down into individual sentences, treating each sentence as a statement or claim.
Okay, sentence by sentence.
Then, for each of these claims, it uses another LLM to perform a series of natural language inference NLI tasks.
NLI, what's that again?
Think of NLI as a way for an AI to understand the logical relationship between two sentences. Does sentence B follow from sentence A? Does it contradict it? Or is it unrelated?
Got it.
So CONNLI essentially asks the second LLM, given the original source text, does this claim logically follow from it? Does it contradict it? Or is it completely unrelated? It does this for each sentence and even for specific entities like names and dates within the sentences.
Wow, that's detailed.
It is. By doing this, CONNLI can pinpoint potential hallucinations quite precisely.
So it's using one AI to essentially grill another AI on the factual basis of its statements. That's clever, leveraging their strengths.
It really is. And the third step is where CONNLI really shines. Based on those NLI results where it identifies claims that contradict the source or are unsupported, it then refines the original AI's response to make it more accurate and grounded.
So it actually edits the output.
Yes, it suggests revisions or flags problematic parts. Studies have shown that ConLI can significantly improve accuracy and reduce hallucinations in tasks like summarization and question answering. Plus, because it flags specific sentences and entities, it can give you insights into why something was considered a hallucination, making the process more transparent.
That sounds incredibly practical for real-world applications. Very cool. What other innovative solutions are being explored?
Well, another really important area of research is focused on how we even measure and evaluate AI hallucinations in the first place. We need good tests, right?
Right. How do you know if you're improving if you can't measure it properly?
Exactly. That's where the TEMS framework comes in. TEMS isn't a method for fixing hallucinations directly, but it provides a way to create more rigorous and challenging tests to see how well our AI systems are avoiding them. Think of it as developing better quality control for AI factuality.
So it's about creating really tough exams to push the limits of AI factuality and see where they break down.
Precisely. TEMS focuses on generating diverse and complex question-answering data sets. It uses a clever technique, weighted random sampling, to select different parts of a text corpus and then automatically generates various types of questions.
Not just simple recall questions, I assume.
Definitely not. They include questions that require reasoning across multiple parts of the text, questions that deliberately include irrelevant or distracting information.
Trying to trick the AI.
Kind of. And even questions that have multiple valid parts or require situational understanding. They even use the very advanced GPT-4o model to generate these tricky questions, ensuring they are high quality and designed to really test the AI's understanding and ability to stick to the facts.
Wow, using AI to test AI.
Yeah. And to evaluate how well an AI answers these challenging questions, TEMS uses metrics inspired by something called RAGAS.
RAGAS.
RAGAS is a set of metrics specifically designed for evaluating retrieval-augmented generation systems, looking at things like how faithful the answer is to the source documents and how relevant it is to the actual question asked. So TEMS helps us create better benchmarks to truly assess and compare how different AI systems handle the challenge of avoiding hallucinations.
So TEMS is helping us build a more comprehensive and rigorous way to test how prone AI is to making things up. That's a crucial step for sure.
Absolutely. Then we have techniques like parameter-efficient fine-tuning, or PEFT. One popular method you might hear about is LoRa.
LoRa, okay. Heard that term.
The core idea here is to take a pre-trained large language model, one that already has a vast understanding of language, and then fine-tune it on a much smaller, more specific data set.
Just specialize it.
Exactly, to improve its performance on a particular task, like reducing hallucinations in a certain domain. In this case, the fine-tuning data would include examples of where the original AI made a factual error, paired with the corresponding correct information.
So it's like giving the AI a focused lesson on its past errors to help it learn not to repeat them, like flashcards for mistakes.
Precisely. That's a good way to think about it. And LoRa is a particularly efficient way to do this fine-tuning because it only modifies a small fraction of the original model's parameters, making it much less computationally expensive than retraining the entire massive model from scratch.
Efficient is good.
Definitely. But while it's effective, this approach does require access to the underlying AI model itself and the computational resources for fine-tuning. So it might not be as universally applicable as, say, a post-editing method like ConLI.
Right, so a powerful tool, but maybe more for those who developed or have deep access to the models. What other strategies are out there?
Another interesting concept that's been mentioned is chain of verification.
Okay, sounds promising.
While the specifics can vary a bit, the general idea is to have the AI not just generate an answer directly, but to also perform a series of internal checks or consult external resources to verify the information before presenting it to the user.
So building in a sort of internal fact-checking mechanism, like, hang on, let me double-check that?
Kind of, yes. Encouraging the AI to show its work or double-check its facts before giving a final answer.
Makes sense.
Then we have Accurai, which takes a very specific and intriguing approach, particularly focused on reducing hallucinations in these retrieval-augmented generation, or AGI, systems.
Okay, focus on RAG.
Accurai's central idea is that many RG-based hallucinations stem from what they call noun-phrase collisions.
Noun-phrase collisions. Sounds painful.
No. It refers to when an LLM encounters semantically similar but distinctly different entities. Think back to our calcium and magnesium example.
Right. Similar concepts, different details.
Exactly. because these terms are related in meaning, the AI can sometimes get confused and sort of blend or conflate their properties or other information associated with them when it's generating the answer.
So the AI sees these related concepts and incorrectly assumes they are interchangeable or gets their facts mixed up.
Exactly right. Accurai tackles this right at the beginning, at the level of the user's query. Their process involves 3 key steps. First, they intelligently split the user's initial question to isolate these potentially colliding noun phrases.
How does that work?
So instead of asking, what are the chemical and physical properties of calcium and magnesium, Accurai might internally rephrase this into separate, more focused questions like, what are the chemical properties of calcium? What are the chemical properties of magnesium? And what are the physical properties of magnesium?
I see. By breaking down the question, they're making it less likely for the AI to get those similar concepts mixed up during the information retrieval part.
Precisely. That's the second step. Accurai only sends these simpler, more targeted questions to the knowledge retrieval system. This ensures that when the AI is looking for information about calcium, it's primarily retrieving documents focused on calcium, and the same for magnesium. They call the results fully formatted facts, or FFFs, small, self-contained pieces of information less likely to cause confusion.
That makes a lot of sense. Keep the information streams separate to avoid cross-contamination effects.
Exactly. And the third step is the remapping. Because Accurai might have modified the original query by splitting it and using placeholders, it then cleverly remaps any of these changes back into the final response that's presented to the user.
So the user gets a coherent answer to their original question.
Exactly. It ensures the answer is coherent and directly addresses the original, potentially complex question. Accurai reports some pretty remarkable results, even achieving 100% accuracy on certain data sets designed specifically to test for these kinds of noun-phrase collision conflicts.
Wow, 100% is impressive. Is there a downside?
The main drawback mentioned is that this pre-processing and remapping can introduce a slight delay, a bit more latency in the response time compared to just sending the raw query straight through.
Okay, so maybe a small trade-off between speed and potentially much higher accuracy, especially in scenarios prone to these kinds of confusions. What other inventive approaches are being used?
We also have a method called refined. Refined takes a different tack. It focuses on evaluating the groundedness of each individual word or token that the LLM generates.
Sort of by word, wow.
Yeah, very granular. It calculates something called a contextualized semantic relevance score, or CSR, for each token.
CSR score. What does that measure?
This score essentially measures how much the retrieved context, the documents the AI found for the RAG process, actually influenced the generation of that specific word.
Okay, so a high CSR means that the word the AI chose was strongly supported by the information it found.
Precisely. RARFind compares the statistical probability of the LLM generating a particular token given the retrieved context versus the probability of it generating that same token without any context at all.
Ah, I see. The difference shows the context influence.
Exactly. If the CSR score for a token falls below a certain threshold, it suggests the AI might be inventing information or drifting away from the source material. That token is then flagged as a potential hallucination.
That's clever.
What's particularly impressive about RARFind is its reported strong performance across multiple languages, even languages with fewer online resources, so-called low-resource languages. It achieves this partly by using a hybrid retrieval system combining traditional search techniques like BM25 with more advanced semantic search methods.
So it's not just about finding relevant documents, but also about meticulously tracking how closely the AI's word choices align with the information in those documents, almost word by word.
Yeah.
That's intense.
It is. Then there's HalluSearch. This technique tackles the problem by, again, breaking down the LLM's generated response, but this time into individual verifiable statements or propositions, like mini-facts.
Okay, breaking the answer into claims again.
Right. For each of these mini-facts, HalluSearch then tries to find supporting evidence using external search engines, primarily leveraging Google custom search and prioritizing reputable sources like Wikipedia.
So it goes out to the web to fact-check each part.
Essentially, yes. If it can't find direct evidence to support a particular statement, it employs fallback strategies. It might extract keywords from the statement and perform a broader search, or even prompt another LLM to generate some context that might either confirm or deny the original statement.
Interesting fallback.
And finally, it compares each of the individual statements against the retrieved evidence and flags any contradictions it finds. HalluSearch has also demonstrated strong performance across various languages.
So it's like having a team of tiny AI fact-checkers examining every single claim the main AI makes using the web as their reference library.
Exactly. That's a great picture. And the researchers found that using prompt engineering techniques, like encouraging the LLM to use chain-of-thought reasoning, where it explains its reasoning process step by step.
Making it show its work.
Right. That can further enhance HalluSearch's ability to detect and flag hallucinations accurately.
It sounds like a very systematic and thorough approach to fact-checking AI output. What other interesting frameworks are out there? We're covering a lot.
We are almost there. We also have the span-level hallucination detection framework. This is a particularly fine-grained approach. It aims to pinpoint exactly which words or phrases the spans within an AI-generated sentence are factually incorrect.
Okay, even more specific than just flagging a sentence.
Exactly. It uses a combination of linguistic analysis techniques, specifically semantic role labeling, SRL, and dependency parsing, to break down the LLM's answers into their core semantic components, things like the actions being performed, the entities involved, the objects, etc.
Getting really into the grammar and meaning structure.
Yes. These components are then compared against the retrieved context using another advanced language model, like GPT-4, to identify any contradictions. The framework even takes into account the AI's own confidence scores the logits for each word it generates, providing a more nuanced assessment of factuality by combining linguistic analysis, external verification, and internal confidence.
Wow. So instead of just saying, this sentence is wrong, it can potentially highlight the specific word or phrase like silver medal or 2008 in that swimming example.
That's the goal, yes. That level of detail would be incredibly valuable for understanding and debugging these issues, and maybe even for automated correction.
It really would. Okay, what else?
And lastly, there's a framework developed at UCSC, University of California, Santa Cruz. This framework follows a three-stage pipeline. First, it retrieves relevant context. Second, it detects any hallucinated content within the AI's response. And third, it tries to map those errors back to the specific spans of text in the output.
Similar goals to the last one, maybe.
Yeah. Similar goals, different methods explored. The researchers looked at different strategies for context retrieval, including using the user's question itself as the search query, but also formulating queries based on the individual claims made in the AI's preliminary answer.
Trying different ways to find the right evidence.
Exactly. They also investigated methods like verifying the AI's claims against knowledge graphs, structured databases of facts, and a minimal cost revision approach to automatically correct the identified errors.
Knowledge graphs, okay.
Yeah.
And minimal cost revision.
Basically, trying to fix the hallucinated text with the fewest possible changes to make it factually correct according to the verified information. While they noted some challenges in accurately linking facts from knowledge graphs back to the specific text spans, their minimal cost revision technique showed promising results in terms of automatically fixing hallucinations, even if it was computationally a bit more expensive.
So automated correction is a real focus there.
Yes. And they also found, like others, that carefully crafting and optimizing the prompts they used with the LLM could significantly improve the overall performance of the framework. Prompt engineering matters.
It really sounds like there's a convergence of ideas here. So many of these approaches are focusing on not just detecting the problem, but also on identifying exactly where the AI goes wrong, down to the specific words, and in some cases, even automatically correcting those errors.
Absolutely. And you see that recurring theme across many of these solutions. The importance of grounding the AI's responses in reliable external knowledge, whether it's retrieved documents, search results, or knowledge graphs, and also employing multiple layers of verification.
Right, checks and balances for the AI.
Exactly. There's also that clear trend towards more granular span-level analysis, moving beyond simply identifying whether a hallucination exists somewhere in the output to pinpointing the exact problematic parts.
Which seems crucial for building trust and actually fixing things.
It does. And while the complexities of different languages definitely present a challenge finding enough data, handling grammatical nuances, the research community is actively working on solutions that are effective across diverse linguistic contexts, like we saw with Refined and HalluSearch.
So despite the inherent nature of LLMs to sometimes make things up, it sounds like we're making incredible progress in developing these, AI confidence boosters, techniques that are significantly reducing the frequency and impact of hallucinations. It feels like it's paving the way for more trustworthy and reliable AI systems. It really does feel like we're on the cusp of a real AI credibility revolution.
That's a fantastic way to put it, an AI credibility revolution. Because while the idea of AI confidently spouting falsehoods can be unsettling, maybe even scary,
Yeah, little.
the sheer volume of innovative and creative research being poured into this problem is truly inspiring. It offers a clear path towards AI that is not just remarkably powerful, but also significantly more dependable.
Which will undoubtedly unlock its vast potential across countless industries and applications.
Without a doubt.
It certainly does make you think. As we become more confident in the factual accuracy of AI, what entirely new possibilities might open up? What things are just too risky now, but might become feasible?
Good question.
Which sectors could be completely transformed by this increased reliability? And among all the fascinating techniques we've explored today, Kanalai, Accurai, Refine, all of them, which ones do you think might ultimately have the biggest impact in different real-world scenarios?
Lots to ponder there.
It's definitely a lot to consider as we continue on this journey into the age of artificial intelligence. Thanks for taking this deep dive with us.